Hi guys, we're working on sine and cosine law now. So you learned these in grade 10, but we are going to go over them again because they are part of the trig unit in grade 11 as well. The sine law states that the sine of angle A divided by side A, which remember is always across from the angle, is equal to the sine of angle B divided by sine B, or side B, and sine of angle C is proportional to side C, which is across from angle C. That formula can also be reversed, where the side lengths are on top and the angles are on the bottom. Typically, we use this one if we are solving for side lengths, because it's always better if the unknown is in the numerator. And that would mean that we use this version if we are solving for angles. Okay, so you choose the correct one you're solving for and make sure that your angles are on top if you're solving for them and your side lengths are on top if you're solving for them. This only works if you know a complete pair. So if you had me in grade 10, you know that I always talked about a complete pair. I think in grade 10, Miss Pepper talked about a golden ratio, maybe. But a complete pair means that you know the angle and the side length across from it. So you have to know either capital B and lower b, or you have to know capital A and lower a, or you have to know capital C and lower c. So you have to know that pair in order to use sine law. If you don't know a pair, if you know what's called side angle side, which means you know two sides and the angle between them, you can use cosine law. So let's say we know side, this angle, and this side, then we can use cosine law. Or if we know all three sides of a triangle, then we can use cosine law as well. So the law of cosines is this formula. We'll be getting to that in a minute. Let's do some practice questions. So find the length of side B in this case. Let's just take our triangle and put on the information. So angle A is 63 degrees. It doesn't matter if it's drawn to scale, and it doesn't matter where I place A, B, and C, as long as I put in the correct sides and angles. So B is 32 degrees, and lowercase a is 12.4, so that's over here. And our goal is to solve for B. So when we set that up, we can see that I actually do have a complete pair of A. I know angle A and I know side A that corresponds to it. And because I know angle B, I'm going to be able to use that to solve for side B. So we're going to set it up with lower cases on top. So B over the sine of 32 is equal to, we'll go 12.4 on the top, over the sine of 63 degrees. From here, if you want the B by itself, we simply need to take the sine 32 up to the other side. So right now this is being divided by sine 32, bring it over to the other side and multiply. So 12.4 times by sine 32 divided by sine 63. Type that in the calculator and you should have a final answer. All right, so we get an answer of 7.4 centimeters, and that's all that question asked for, so that is enough. In triangle DEF, let's go with DEF here, here, and here. 80 degrees is D. Again, that's definitely not to scale. That's okay. Side E is 10.2 and side F is 12.4. And our goal is to find lowercase d, so this is the one we don't know. In this case, we don't have a complete pair. We have 80 degrees, but we don't know the angle, the side length that goes across from it. We have 10.2, we don't know that angle that goes across with it. And we have 12.4, we don't know that angle that goes across with it. So without a pair, what we have here is side angle side, we have this side, we have the angle in between, and we have this side. So that is cosine law. With cosine law, we're always going to start with the lowercase letter that we're looking for. So since we're solving for lowercase d, we'll do d squared equals, and that means this is going to be e squared and f squared, because those are the two that you know. So e and f is what you know. It's always in the formula minus 2 times those same two sides, whatever sides used here. And it's always times the cos of the capital corresponding one. So these two will always match. So if you are solving for lowercase d, you must know capital D in order for it to work, which we do. Here we can just put everything in. 10.2 squared, 12.4 squared, minus 2 times 10.2 times 12.4 times the cos of 80 degrees. And I do recommend typing that all in one step in the calculator. It just will save you a bunch of time and get used to just using your calculator in one fluid motion. So 10.2 squared plus 12.4 squared minus 2 times 10.2 times 12.4 times cos 80. And then if you want to, in that exact same step, you could take the square root. I will show it without the square root though. Okay, so that turned out to be 213.87. It does keep on going. I'll just put a couple dots there to show that it keeps on going. But when I take the square root, I'm going to make sure I take the square root of the entire number that's on the calculator to keep it the most accurate. So our final answer is 14.6, and that would be in terms of meters, like the original question. All right, so that was one example of sine law, one example of cosine law. We have here okay, so I set up the cos law. I subbed in 3.3 for my A value. I subbed in 4.2 and 5.1 for B and C. And I did that again here for B and C. And cos A is what we're solving for in this question. So because we are solving for cos A, I had to make sure I began with lowercase a. So in order to isolate cos A, I'm going to go through and figure out some of these answers. So we're going to do 4.2 squared plus 5.1 squared in one step. And we're going to do these three in one step as well. Okay, so we're at the point where we have 10.89 equals 43.65 minus 42.84 cos A. This is attached to the variable. It's like having a 42.84x. So we actually cannot combine it with this 43. It's not a like term, right? This is a plain 43.65. This is like a 42.84x. So in order to isolate this cos A, I have to begin by bringing 43.65 across. And we're going to minus it off because over here it is adding. And then on this side, we're going to be left with negative 42.84 cos A. We can subtract that to get the answer, and then we'll eventually divide by this negative 42 to get cos A by itself. So we get negative 32.76 over here. We've got negative 42.84 cos A over here. We're going to divide both sides by negative 42.84. And we are going to be left with an answer for cos A as 0.76, and again, it keeps on going. Remember, that angle is not 0.76 degrees, and it's not 76 degrees either. That's not the way those decimals work. You have to get rid of the cos by doing the cos inverse. So in our final step, we're going to bring cos inverse across for that 0.76. And I keep those dots there to show you that I am keeping the whole thing in the calculator. So I'm not clearing the 0.76 off my calculator. I'm just going to go second function, cos inverse equals, and I have an answer for angle A of 40 degrees. All right, for the next one, we'll go J, K, and L here, here, and here. J is 67 degrees. Lowercase j is 14. Lowercase k is 12. And our goal is to solve for angle K. So once again, we have a pair. The 14 and the 67 are both capital and lowercase j. So we can use sine law again. And sine law for an angle means we should do angles on top. So we're going to go sine k over lower k equals sine j over lower j. Okay, I'm just setting it up so that my unknown is first because I like my unknown on the left side. So let's fill in what we're given. Lowercase k was 12. Capital J was 67. Lower j was 14. We want to get that sine k by itself. For now, we've got to keep it together and just bring the 12 up. So we'll do 12 times the sine of 67 divided by 14. And then to get rid of the sine, we'll have to do the sine inverse. So we're going to end up with sine k equals some decimal, whatever that turns out to be. And then to get angle k, capital K, we're going to do the sine inverse of that decimal. So we ended up with a decimal of 0.789, keeps on going. We take the sine inverse of 0.789 and we get angle K to be a 52-degree angle. Okay, this question is a practice question. It's basically for you to work on for homework. We are going to do this one together. A ship at sea heads directly toward a cliff off of a shoreline. A crewman is looking out at the window at sea level and sees an angle of elevation of 30 degrees to the top of the cliff. The boat moves 30 feet closer to the cliff, and now the crewman sees it at an angle of 45 degrees. What is the height of the cliff to the nearest foot? So let's just draw the cliff. The boat is out here, looking to the top of the cliff, and they see that at a 30-degree angle. So this is the original boat. Let's do OB for original boat. Once the boat has traveled, they get to their new position. And we'll call that NB for new boat. It's their new boating position. They're now looking up to the top of the cliff at an angle of 45 degrees. And we also knew that they had traveled 30 feet in that time frame. So from the original boat to the new boat, it's a distance of 30 feet. Our goal is to find the height of the cliff. Let's call that H. And we only have this information for now. So we have 30 degrees and 45 degrees. Remember, if you're on a straight line, this will add to 180. So we can figure out this. This will be 135 degrees. A cliff is assumed to be a 90, so we're looking up. And the reason it's a 90 is because we're talking about height, and height is the direct distance to the ground, so that is at a 90. Okay, what do we know so far? Well, we know only one length, and that's the 30. We're going to have to use the 30 to figure out more about this triangle. Now, because we know these two angles, we can find this upper angle within this triangle here. So I'm going to focus on this triangle. And our goal is to find this upper angle because then we'll have a complete pair with a 30 feet. So we can do 180 minus 30 minus 135, and we can figure out this upper angle. So this combines to make 165, and from 180, that is a 15-degree angle up here. Our complete pair of 30 feet and 15 degrees is going to help us find this side length. And the reason this one is important is because this side length will help us with this triangle to find the height. So we need to find this corresponding side length because they share these two, and then we can use that to find height. So we'll do sine law to solve for x. I'm going to go with x on the top, and that's going to pair up with the sine of 30 degrees because it's across from the x. On the top over here, we're going to have 30 feet, and that's going to pair up with the sine of 15 degrees. So I'm pairing this with this. They correspond to each other, and I'm pairing 30 feet with sine 15. So here we end up with 30 sine 30 divided by the sine of 15. That'll give us our distance for x. Which is 57.96. Let's use 2 decimal places. So we now know 57.96, and because this second triangle here is a right triangle, we can use SOHCAHTOA to solve for height. So this is the opposite side. And we just figured out the hypotenuse. Opposite and hypotenuse is sine. So we're going to do the sine of 45 degrees equals opposite, which is our height of our triangle, or height of our cliff, divided by the hypotenuse, which is 57.96. And then we can get h alone just by bringing 57.96 over and multiplying by the sine of 45 degrees. Once again, since 57.96 is still on my calculator with all the decimals, I'm just going to keep all that in the calculator and times it by the sine of 45. The more you can keep the numbers in the calculator and not round them mid-calculation, the better. And we'll have a final answer of 40.98, which we can actually round that to 41.0. And that would be in feet, since the question was talking in feet. So there's your height of your cliff. And it does ask for the nearest foot, so that made sense to round it to the nearest whole number. One more question. I want you to do this one on your own as well for homework. I will get you set up with this picture though. So we have an office building, and we have a sign on top of the office building. So it's like a billboard facing out. So when it says it's a 15-foot sign, it means it's 15 feet on top of the office building. And then when you're looking up to the top of the sign, you were looking to the very top of that triangle. And then when you're looking up to the bottom of the sign, you're looking to there. So it's very similar to the boat question, but it's a different perspective in terms of you're not changing where you're standing, you're just changing where you're looking. So give that one a shot. See if you can figure out how to do that one. You're looking up at an angle of 40 degrees for the top of the sign, so that's this entire thing, and just 32 degrees for the bottom of the sign. Okay, I'll let you finish the rest of that. And of course the homework that was on grade 10 review as well. All right, bye guys.